Good evening, my YouTube viewers. This is Crystal. What I had done today is I had looked on my GitHub account and I found that individuals who are reading my blog post are actually going onto my GitHub account and they are forking the programs that I've written, because obviously I make my programs freely available, so if anybody wants to use them, they can use them. And I thought, well, if people have an interest in reading about the predictions of current events, then perhaps I should make predictions on current events. So what I have done is I've decided I'm going to do a little bit of work on COVID. But the thing that you need to know about COVID is that it's coming from a website. It comes from this website right here, https //rworldindata.org /coronavirus-source.data. They update this website every single day. So if you're going to do some work on coronavirus, you got to do it that day, because the following day the CSV file is going to be updated, and so your information is going to be out of date. And as a result of that, I decided, well, I need to go ahead and do this quickly. Now, what I had wanted to do is I wanted to do a prediction in FB Profit, and I wanted to have a multi-target output, but I don't know how to do that in FB Profit. And what I did was I even posted the question on Python to see if it's possible to have multiple targets, because in sklearn you can have multiple targets. So it would be really good if you could have multiple targets in FB Profit. But until Stack Overflow gets back to me, I'm not going to know if you can do it. So what I've done is I've used FB Profit to make a prediction on COVID. So what I've done is I've taken all of the data that they have up until today, and it's a very simple univariate time series analysis, because I did a multivariate time series analysis on something else, and it didn't really change the reading so much. And because it didn't really change the reading so much, I decided that we'll just keep it simple for the time being. And as I progress in studying COVID-19, I will make my models more elaborate. So the first thing we did is we downloaded the CSV file from this website, which is updated every day. So every day that you work on the CSV file, you are going to have to reload the data, because every day the data that you used the day previously is going to be obsolete. And so what we did was we opened up a program on Google Colab, because Google Colab is a good online Jupyter notebook to use. And the reason why is because a lot of the libraries are already installed on Google Colab, and because a lot of the libraries are already installed on Google Colab, you don't have to worry about installing them on your personal computer and making sure that you have the most recent version on your personal computer. So the only thing that we've imported at the time being is pandas and NumPy, and as we go along we will be importing other libraries. So we imported pandas and NumPy, and then I had to save the file to my Google Drive, because it was 12 meg, I believe. And because it was 12 meg, it was too big to put it into GitHub. And even though it's too big to put it in GitHub, because it's updated every day, then it's going to be obsolete. So there you go. So it doesn't really make a whole lot of sense to put it into GitHub because it will be obsolete. But I did actually make a GitHub account, and this program is stored in the GitHub account. But what I'm going to do is when I do my blog post, then what I will do is I will give the link to my GitHub account to the blog post. So if you want to know what the link is, then you need to read my blog post. And so I get paid for people reading my blog post. So I have an incentive for people to actually read my blog post, which is why I freely give out the code to get people to read the blog post. And obviously I haven't won any competitions, so there's not really a whole lot of point in me keeping my code to myself, because although my code is okay, it's not competition winning. So we loaded our data set and we read it, and you can see there's lots of information in here. It tells you your ISO code, your continent, your location, your date, total cases, new cases smoothed, total death, new death smooth, total cases per million, new cases per million, new cases per million smooth, total deaths per million, new deaths per million, new deaths smooth per million, reproduction rate, ICU patients per million, hospital patients per million, weekly ICU admissions per million, weekly hospital admissions per million, new test, total test per thousand, new test per thousand, new test smooth per thousand, positive rate, test per case, test units, total vaccinations per 100, stringency index, population density, median age 65 or older, age 70 or older, GDP per capita, extreme poverty, cardiovascular death rate, diabetes prevalence, female smokers, male smokers, hand washing facilities, hospital beds per thousand, life expectancy, human development index. So there's a lot of information that we can research on this COVID-19. This is a very in-depth data set. So what I did was I did the info command, and all of these columns that I just read out to you, they're actually here. And we have 52 columns, I believe, because the first one starts at 0. So since the first one starts at 0, we have a total of 52 columns. So what I've done is I just wanted to see UK because I'm living in the UK, and that's what I want to see. And as I go on and do more work, then I will be working on other countries, such as the US. But for the time being, I'm just going to be working on the UK. So what we did was I just called up just the UK. And so we can find out all this information on the UK, and it gives you all this information that I just covered previously. So I'm not going to read the columns out to you again because it's pointless. We don't want to duplicate our efforts. And then so what we did was I created a new data frame, and I called it UK new case equals PD data frame. And then date is include UK.date, and new cases is include UK.new cases. So we've got this new data frame called UK new case. So this is all your new cases. And it's done in date. It gives you the date and the new cases. So this is going to be a very simple FB Profit program, because the thing about this COVID-19, because it's updated daily, if you're going to do some work on it, you have to do the work quickly. And what I found when I was working on something else, it doesn't make that much of a difference if you add columns to it. So I decided I'll just leave it like this for the time being, because we can do lots more work on this data set. There's lots of information that we can work on. So we have to rename the columns. Date is DS and new cases is Y, because that's what Facebook Profit wants to see. And what we've done is we've graphed the time series. So you can see they've graphed all this. And you can see that it's, we had a peak in cases. So we had a lot of new cases. And then we had a dip. And then now we've got a peak again. And the reason why we've got a peak again is because this virus has mutated. And that is one of the reasons why I'm not really keen on getting a vaccine myself, because the virus has mutated. It's not mutated once, it's mutated twice. So one of the mutations is coming out of London. So like London and the surrounding areas are in tier 4, which is like lockdown. And I'm living in Reading, which is close to London. So I'm in tier 4. And it's a good thing that I have my boyfriend, because these people who are single, I'm sure they're in a terrible situation. And then the second mutation is coming out of South Africa. So what they're doing is they're stopping travel. They're stopping travel in and out of the UK because this virus has mutated. And I believe they're doing the same thing in South Africa, but I can't be sure because I just mainly hear UK news. So that's why you can see towards the end of the graph, we've had a spike because this virus has mutated. And so that's why it's always a good idea to actually put your time series on a graph so you can look it up and see exactly what it's doing. Now what we're doing is we're splitting our time series up for training purposes. But what I wanted to do is I wanted to create a test data set. So I created this test data set. By the month is 2021-01. So that means January 2021. And I used this code to create a data set. So every row is a date. And we're not going to have a Y column, because that's what we're going to predict upon. So we have to rename our columns. So we renamed our columns, our date column, to DS, because that is what Facebook Profit wants to see. They want the date column to be DS. So now what we've done is X train is UK new case loc, UK new case DS, 2020-12-01. So that means 1 December 2020. Everything before 1 December 2020 is what is going to be, the model is going to be fit and trained on that. And then our validation set is everything after 1 December 2021. So it's going to be about 24 days that they're going to make predictions on 24 days. And so we've set the test set. The test set is going to be everything after 1 January 2021, but it's only going to be 1 month. It says it's only going to be 1 month that they're going to be predicting on. So you've got the you've got the train set, which is going to X train, which is going to be close to a year, and then you've got X val, which is going to be over 3 weeks validation, and then you've got X test, which is going to be a month. So now what we do is we set up our FB profit. So model equals profit, and then you can also set up parameters per profit, but I didn't do that. And then model fit equals X train. So we're going to train and fit X train into the model. Now what we're going to do is we're going to predict on the validation set. So forecast equals model dot predict X val drop columns equals Y, and then forecast. So now you can see the forecast. But what we're looking for, I'll show you what we're looking for. We're looking for this last column right here that says Y hat. That's what we want to see. We want to see Y hat. And then now we check our RMSE. And so our RMSA is 8461, so that's pretty high. So we have a very high error rate. And the last time I predicted on something, I had an RMSE of 30. So you can tell we've got a high error rate, but we're going to go ahead and do this anyway. Because we could actually put the time series on stats models, and I might actually decide to do that, decide to put the time series on stats models and see if that improves the accuracy. But I really do like Facebook Profit because it's really easy to use, except for the fact I don't think it will let me do multi-variables, but I can do some sklearn modules that I think will let me do multi-variables, and I might try that out as I'm working on COVID-19 work. And then so what we're going to do is we're going to forecast on YCAT. So anything below 0 automatically becomes a 0, and we're going to make a data frame so we can compare the actual values against the predicted values. So you can see the actual values and you can look at the predicted values. And this is the chart. So you've got a graph of your X train, your training set, and then you also got a graph of the validation set, and it goes all the way up to January 21. So this is a diagram of the model, and if you're into charts and you know how to read them and interpret them, then that'll give you a lot of information. So now what we've done is we're doing some more plotting, but I guess it didn't pick up the plotting. Normally it would pick up the plotting, but sometimes on GitHub it doesn't pick up the plotting, and in this instance it didn't pick up the plotting, but it did do the plotting on Google Colab. It's just for some reason it's not doing it on GitHub. And GitHub is just a mechanism that allows you to view the code, but apparently you can create files on GitHub as well, but I've never tried that. I've always just done everything on Google Colab and then copied it into GitHub. So now what we're going to do is we're going to predict on our test set. So here we go. We've got our predictions for our test set, and what we're looking for specifically, if I can find it, we're looking for this last value right here, I believe it is, which is your Y hat. That's what we're looking for, is Y hat. And the reason why they call it Y hat is because it's Y and it's got this funny shape on the top of it that looks like a hat, and so that's why they call it Y hat. So now what we've done is we've made a data frame. So we put the prediction in the data frame. So we put the date, which is test.ds, and new cases, which is prediction.yhat.values.astype int. And then so we output that to we make a CSV file, but we've got nothing, we've got nowhere to put the CSV file. But if you wanted to look at the CSV file, you could. And then we make a, after we created this CSV file, you can read it. So what this does is this tells you what the predictions are going to be for all of January, for January 1st to January 31st. And then I thought, well, I'll make some a graph of that so you can see a graph of the training set. The validation set is missing, but you can also see a graph of the January 21. So that shows you what your prediction is going to be. And again, we've got some more graphs if you like looking at graphs and you want to interpret them. And we had some more graphs that they came up on Google Colab, but for some reason they're not coming up on GitHub. I think that again, GitHub is just allowing us to view the code, and maybe it's too memory intensive to do that. So that concludes this video of the predictions for the new cases of COVID-19. And tomorrow I'm going to be doing some more work on this data set as well. And I'm going to work on this data set for a while, but you need to understand that every day I'm going to have to upload the CSV file because every day they update it. And since it's updated every day, the day previously it's out of date. So I'll be doing my best to get you up to date COVID-19 predictions, and we'll see what we can find with machine learning. And I'll do my best on that. I would like to say, I think his name was Neil Ferguson. Apparently, he made a lot of predictions on COVID-19, and he was using a program that he had written in Fortran. And Fortran is really old. Fortran is over 30 years old, definitely older, because when I was doing my computer studies 30 years ago, I didn't get the opportunity to take Fortran, and I believe Fortran was already old then. So Fortran is probably close to 40 years old or older. And this model that had been used by this Neil Ferguson had been written in Fortran, which is a 40-year-old program. And apparently he'd used an incorrect model. Now, I researched all this stuff and found all this stuff out when they had that fiasco with Neil Ferguson because he breached lockdown. And then I started studying data science. So now I have greater understanding. I knew what Fortran was, but I didn't know what he meant by model, and I know what he means by model now. So I will be discussing that in my next blog post as well, and I will be discussing why I feel my model is more accurate than the model that Neil Ferguson made. So this concludes my presentation on the new cases of COVID-19 and the prediction for January 2021. If you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I've got my email address to my PayPal account in the description box down below. I don't have enough subscribers to monetize, which is why I have to ask for donations. And thank you so much for watching my video, and I look forward to making new videos for you.